Before we get into talking specifically about the properties and definitions of acids and bases, let's make sure we understand the properties of all solutions. That only includes another two different types of solutions. One of them is molecular. Now, a molecule, remember, is where you get non-metals coming together, and when they bond together, they form compounds that, when you dissolve them into water, if you can dissolve them into water, they're going to be non-electrolytes. Now, what does that mean? A non-electrolyte means you don't conduct an electrical current. So, if you stir a molecular substance into water, and then you test its conductivity, you'll find that it won't conduct. Water's molecular too, although water's kind of special because it does ionize a little bit. So it conducts to an extremely little percent, but it sort of does. So here's the thing about molecular solutions though. If a molecule does dissolve, if it's polar, remember that? Because water's polar too, like dissolves like, then it will have a pH of 7. So if you had a colorless solution of a pH of 7, you can't tell if it's an ionic type of solution or molecular just based on those two properties. But the electrolyte part, now that's the diagnostic feature, which means that's an exclusive property to molecular solutions. They are non-electrolytes. If you get something that doesn't conduct, it's molecular. And some examples are things like, well, here's sucrose and glucose. Oh, maybe even C2H5OH. Not even, that's for sure. That's ethanol. Ethanol, drinking alcohol, does not conduct a current, and neither does something like methanol, something you wouldn't drink because that's wood alcohol. That's the gas line antifreeze. So, molecular solutions, non-electrolytes, very important. Some solutions that also have a pH of 7 but are different than molecular are neutral ionic solutions, and those solutions conduct electricity because they're ionic compounds, and when they hit water they break down into ions, charged particles that allow a current of electrons to pass through. So they're electrolytes, which means that they conduct electricity, but the pH is still 7. So if you've got a pH 7 solution, it might be neutral ionic or molecular. Can't be an acid or a base. They can also be colorless, but sometimes have a little bit of color. Some ionic compounds can have that. But here are some examples that are very important to recognize a kind of a trend in. So sodium chloride, potassium iodide, calcium nitrate, lithium bromide, examples of neutral ionic compounds. But it's the negative ions that really make them neutral. Br, NO3 negative, I negative, Cl negative. You're going to see pretty soon when I put up a list of strong acids that all of these ions are the conjugate bases to a strong acid, which means you just take the H off of an acid and what do you have left? That ion by itself in solution or attached to usually group 1 or 2A elements, they're neutral in nature. They're the ones that have a pH of 7. The conjugate bases of strong acids.